In this video, we will see a function for finding factorial of a number. I will show you recursive function as well as iterative function. So first let us write recursive function for finding factorial. Function takes parameter n. If n is equals to 0, then return 1. Else return factorial of n minus 1 with n. Inside main function, I will take a variable r to get the result of that factorial function. Let us find the factorial of number 5. The answer is 120. We already know the answer. We should get the same result. Display r. I will run the program. We should get the output 120. Yes, the output is 120. It's a factorial of 5. Let us check factorial of 4. It should be 24. Yes, it is correct. Let us check factorial of 0. What the result will be. It is 1. Let us use a negative number here and see what the function will do. Factorial of minus 1. See, when the value of n is minus 1, then it is not 0. So it will be calling itself again and again, minus 1, minus 1. So it's minus 2, then minus 3, minus 4, goes on. So actually it has gone into infinite calling and terminated. So you can see total how many calls it has done. 262054 calls it has done. Then why did it stop? Because of stack overflow. So if a recursive function is going into infinite recursive calls, so at one point it will terminate because of stack overflow. System stack has overflown, so it has made so many calls. Factorial is not defined for negative numbers. So if you want to avoid this recursive call, so then here you can write a condition to stop the function if the number is negative. Now I will write an iterative version of factorial. I will call it as ifact. It takes a parameter. And for finding factorial, I will take f, that is initialized with 1, and also we need a variable I for iteration. Using for loop, I assign 1 onwards, and I less than or equal to n, I plus plus. Then factorial is multiplied by I. So I will be taking different values from 1 to n, and it will be getting multiplied by f every time. So this will be multiplying just like 1 into 2 into 3 into so on to n. Then finally return f. F is having the result. And here inside main function, I will call this I factorial function, and I will pass the parameter as 5. Let us run the program and see what the output will be. It should give output 120. Yes, output is 120. Let us debug the program quickly and see how the values of f and I are changing in this iterative version. So you can observe this watch here. Watch this portion where the values of fi will be changing. I will continue execution. It will enter into factorial function. Now the variables I and f both are there. I is 1, so 1 multiplied by f, f is also 1. Then I becomes 2, multiplied by f, f becomes 2. Then I becomes 3, multiplied by f, f becomes 6. Then I is 4, 4 is multiplied, 24. I is 5, 5 is multiplied, 120. I becomes 6, then it will stop. And come back to main function and print the result. So end of program. So that's all in this video. We have seen recursive as well as iterative version of factorial function.